Welcome back, everyone, to another presentation up to the time. Today, we are going to be focusing on flat roofs. So what does the term flat roof mean? A flat roof is a roof which is almost level in contrast to the many types of slope roofs. The slope of a roof is properly known as its pitch, and flat roofs have up to approximately 10 degrees. Flat roofs are an ancient form most used in arid climates and allow the roof space to be used as a living space or a living roof. Now, there's a term that you would hear me use, which is called roof flashing. So what is roof flashing, or what is a roof flashing? Roof flashing is a thin material, usually galvanized steel, that professional roofers use to direct water from critical areas of the roof. Wherever the roof plane meets a vertical surface, like a wall or a dormer, that is where a roof flashing would be used. So now that we have defined what a flat roof is, I'm going to show you some examples of flat roofs now. So here is a flat roof. Let me just take out my annotation so everyone can see. Yeah. So here would be a flat roof. And also this area will be flat. And also here will be a flat roof. All right. These two, 1 and 2, carry a parapet wall. This doesn't. All right. So let us clear and then move on. This is what is known as the term roof flashing. So here is the roof flashing. Whereas the roof plane meets this vertical wall. So this roof flashing to stop water from going in and to stop water from settling around here too and penetrating the surface. So that's all the roof flashing there is to do. And it's a metal, it's aluminum sheet. All right. But let us proceed now. So let's see, this is the flat roof. Here you can see the slope. That's the slope. That slope allows for water. So imagine when the rain falls onto here. These would be the raindrops, and then it would flow off in this direction. Right? And perhaps it flow down here. Okay. I don't see any gutter, so it would just flow off, right? This would be the flow direction of the water. All right. So that would be the purpose of having a slope on your flat roof. Let's go back here. Now this shows a flat roof from an aerial perspective, which I quite like because it's able to show the parapet walls. Right? So first thing, this is the flat roof here. Flat roof here. And then you're able to see these walls. What I mean, these walls are known as parapet walls, right? These are the parapet walls here. Walls that go past the roof level. And although these roofs look flat, they're not directly flat. They have a gentle slope of 5 to 10 degrees, which allow the water to drain off. Right? And look, and you can see what I've just noticed. So clearly drawing. These are downpipes. So what will happen is the water will be from here, will be drained into here, then it will spit out here, and it will go there, and it will come out through this, and then it will go down to the ground, right? So that would be the path of the water. and going through these downpipes. And these pipes are basically to get the water off the roof and bring it down to the ground level so that it can either be distributed in a soak away or an area where you might want to water your plants, or you might even want to store the water after you get it off the roof. Okay. Let's move on. Let's look at this one. This is a timber flat roof. So what we were looking at before was a concrete flat roof. And you can see the timber members here, which go to support the roof. Different members. And again, the flat is slope. So that means if the water were to drop here, it will be sloped off in this direction. And it will probably be drained somewhere here. And it will go down to the ground. So that's another flat roof, a timber flat roof. Okay. Let's just continue. Let's see what else we have. This diagram shows a lot of information. Now, this diagram shows flat roof drainage system. Let's analyze this, because once you understand this, you'll be able to actually construct and design flat roofs, understanding how to slope and how to drain them. So there are three styles here. There's style 1, there's style 2, and then there's style 3. Let's look at style 1. Style 1 gives you the option of draining to the left, or draining to the right. So although this is sloping here, this would be seen as the high point here that I'm putting a dash line on. And then everything is distributed to the left or to the right. And then the water will then flow in this direction, and the water will flow in that direction. And what will happen is the water will go through this drain, and go into this pipe, and then it will be distributed down to the earth right here. On this side, and also on this side too. A similar situation would occur on the left, would occur on the right. Now, let's move over to style 2. Style 2, everything is drained in the middle. And there's an internal drainage system in here. So what might happen, let's just assume there might be a column inside, and within the column, there's actually a pipe. So the water will come from the roof, and everything would be channeled to the middle that we can see here, And there would be a pipe in the middle, and this pipe would receive the water, and the pipe might be concealed within a column. So as when you're in the house, you wouldn't even tell that the purpose of that column there might be to drain water from the roof. You would just see it as a column in the house, and you might think it's there for structural purposes, but it's there to drain water from the roof, and it would drain it to the ground. Or it might be stored in a water storage system. That means that there might be a water tank under the house storing the water from the roof, right? So that is style 2, and it says here internal drainage system, and that would be relating to this one. Style 3. Style 3 is the one most people tend to drain all the water in one direction. This would be a high point, so I'll put H there, and then this would be the low point, and the water will move from high to low. And then there's a gutter to receive the water right here. Right? So what happens is this gutter receives the water, and then it is channeled into a downpipe. And then the downpipe carries the water to the ground. All right, so those are the 3 flat roof drainage systems, and the 3 different styles you can design your flat roof to allow for water to be drained off properly. So I think everyone has got that. I am now going to clear the drawing and let us now move on. The 3D model. Okay, so what do we have here? I have a flat roof. I have it exploded so that all the members are floating in the air so that we can analyze what goes into making a flat roof. In other words, what are the ingredients or the members that you need to add to create this flat roof, or you need to combine. So let us start off by analyzing a timber flat roof first. But both of these are actually timber flat roofs, right? I don't have a concrete flat roof here. But if we understand the timber flat roof, it'll be easier for us to understand the concrete flat roof. So let's start off here. Okay. So this member here that we will start off with, let me just clear the drawing. Let me clear the drawing. All right, cool. So this is our block wall. This is our block wall. This is made out of concrete here, right? As you can see, material. This now is a roof joist. So we'll put here roof joist, roof joist. I was looking to see if I can get this at a different style or a different size. I don't know. I not want to waste time. So this is roof joist there. And this is a timber. No, this is a concrete block wall. All right. What else do we have here that we can point out? We have here the tongue and groove boards. These are the tongue and groove boards. Above here, this is a tapered firing piece. Like that. That is a tapered. That is a. So this is a piece of timber that starts off high, or I shouldn't say start off high. It starts off with a high point, and then it's tapered down to a low point here, which takes on the profile of the 10 degrees, sorry, the profile of either the 5 or 10 degree slope that the roof needs to be designed at so that the water can flow off, right? So if you realize this is flat, this is fairly flat, or what I would say parallel to the earth surface. This one is fairly flat or parallel to the earth surface. This one here has the slope. This member has the slope. So the slope is now introduced by the tapered firing piece, right? That's what I want everyone to understand. Now, above that, so what goes above that here, we'll just start to note from here. Above that is the built-up felt. Yeah, built-up felt. Built-up felt. Or some people will use the water-resistant material there. Water-resistant material. Right. Down in this area is where we will put the flashing. Okay, so we just circle it here. At this joint here is where we will have the flashing. You know what? Let me just put that a little smoother. In this area here, this is where we will call it our flashing. Okay. We'll put metal flashing. Metal flashing. Right. And what else do we have here that we can call up? Lastly is the parapet wall. And this would be the parapet wall here. That would be the parapet wall. So this here is all the members that go together to make a timber flat roof. Oh, I'm forgetting one more member. What am I forgetting? I'm forgetting over here, which is the fascia board, which this member actually receives the gutter. So that is the fascia, FASCIA board. This is usually a timber member. All right. So I hope that students are able to better understand what's going on here. And then I will get into now sizing these members. So these are what the members look like when the isometric or the perspective is exploded. Now I'm going to show you what these members look like now when everything is connected. Let me just clear here. Good. Let me move on to this one now. So we can see here when everything is connected, where the roof joist goes. You can see where the tongue and groove board goes, and we can see the tapered member, which is in yellow. You can see here on top is the built-up felt. Here's the parapet wall right here. And you probably wonder what these are. What are these? What are these? These are water drips. I've explained this in a video before, but I will just briefly explain this now while I'm here. So what happens is when the water drips here and it's trying to roll off, it will go in this direction. And if you don't have these drips, it will go here and it will just flow down the face of the wall. And what will happen is eventually this face will get very dirty and it will get ugly. So what the water drip does is it channels the water in this direction. It goes through the drip. And when it gets to the point here, at the high point in the drip, it just drops due to gravity. So why is this important? That means that the water drops without actually staining the wall. It drops in space freely. All right. So that is the purpose of the water drip. So that is why that water drip detail is there. Okay. So let's just get past that. So this is a finished flat roof, timber flat roof. And we can see it. Obviously, this will be the inside and this will be the outside. All right, now, I think I've shown you all enough of this three-dimensional model. And I've also discussed the materials that will be used. Let us have a look at some of these materials, because I mentioned materials such as flashing and felt. So let's have a look at what felt looks like. This is what built-up felt looks like. Yeah. This is the material felt there. Let's look at another. Look, this is how the felt comes. This is a different color. These are the different roof flashings. So you can clearly see that the flashing is a piece of metal. A piece of metal, and it's the same metal material that will be used to create the gutters, right? As you can see, this is a gutter here, as it says. And this here is a flashing. And the reason why these are designed and the shapes look different is because they go different places. This is a flashing for a ridge on a pitch roof. As you can see, it has the profile here, like a pitch roof, going up like that triangle style. This is the flashing here for eave, right? So this will be at the end of the picture, probably around here, is where you will see this style flashing at the eave. Then there's a corner flashing, a valley gutter, a top flashing, L-type flashing, gable wall flashing, bottom flashing, and valley gutter flashing. These are just the metal just shaped to accommodate the area that it needs to protect. That is all. So I just want everyone to understand the flashing. Yeah. Okay. So I think I've explained that. And I can move on. Just before we move on, the next stage of this presentation. This is how a flat roof will look on the inside. And this is a timber flat roof. And you can see this has some skylight. So these are the skylights here, which bring light in from that point. They also have a light here, and it has a fan, a ceiling fan. But for the most part, this is a timber flat roof, and this is what the view would look like from the inside, what a person would be experiencing. Okay. Now, let us move on to looking at a drawing that we are going to be creating. All right, so I'm just going to be showing this drawing now. And these have two flat roofs here. And I'm just going to be discussing this for a short period. And then we're going to get into creating this drawing. All right, so let's look here and see what we have here. This is a timber flat roof. And then this one down here is a concrete flat roof. So I've spent some time going through the timber flat roof before, especially in the model. So I will use this opportunity to go through the concrete flat roof. So what's the difference? The main difference is this. That's the difference right here. That is the main difference. This is a roof joist, which is made from timber, and this is a concrete reinforced slab. Right? They're both the size of 150 mil. Within the concrete slab, there's steel. This is the steel highlighted here. Then there's steel bars and stuff like that, right? The steel bars. Okay. Now above the concrete, the steel, above the concrete slab, we have 1.3 sand/cement screed, which is here. Right? This detail is made up of sand and screed, whereas this detail here is made out of a built-up piece of timber. Right? That's the difference. But after these two differences, the detail is pretty much the same. So if anyone were to ask the question, what's the difference between a timber flat roof and a concrete flat roof detail? The concrete flat roof, the slab is 150 mil and it's made out of concrete, whereas the main support is a timber joist, which is made out of timber. Above the timber joist, we have a firing piece, which is a tapered, what do you call a tapered triangle here, which actually is the profile of the slope. That is put in as a one piece. Whereas down here, this is built up with sand and cement compact together to form a screed. So those are the two major differences there. Everything else is pretty much the same. And let's highlight the flashing. This is where the flashing will go, right here at this corner or this joint. And then again, it's the same flashing. What else do we see here? DPC. What does this mean? You see it on both details. DPC, that represents damp proof core. that there is a moisture resistant material to stop moisture from coming from outside and coming into the building, right? So that's material. Looks like a black garbage bag that is placed on to stop moisture from entering the building. It's also found in your foundation too. So you would see that same material in your foundation detail. Okay. All right. Let's see. Let's move on. So I think that's the major difference here in these two details. Now, what is the strategy that we're going to adopt for creating this? Well, the first thing, we need to look at the specifications. And in looking at the specifications, I'm going to also be showing you all a finished drawing. The finished drawing is in AutoCAD. So let's look here. This is an AutoCAD drawing, and this is what we will be doing today. We will be drawing a timber flat roof. Yeah. Also be drawing a concrete flat roof. And we'll be drawing both of these in orthographic projection, which is in a two-dimensional format. And then after, we would be creating these in a three-dimensional format, which is isometric projection here, an exploded isometric projection. What is an exploded isometric projection? When the members in the isometric are floating, they're not touching each other, right? They're exploded so that people can look and see how each member is laid down rather than everything stuck together. I find that some students understand it better that way. So for this particular project, I'm going to be creating an exploded isometric projection. All right, so that there is what a finished product will look like. Now, let us get into the specifications that we need to adhere to. Right? So these are the specifications here. Now, let's read them. Specifications, walls. All walls, concrete blocks, 150 millimeter thick. So let me just put my specs here. And yeah. So let's cross-reference so that people would understand what these specifications mean and why they're so important. So we're talking about the walls, right? All walls are 150 millimeter thick, which mean here, the plaster on both sides. So this is a roof joist. Where else do we find a roof joist? So we're going to find the roof joist here, right? And that's 150 mil thick, and it's a timber member, all right? Let me just clear off this before it gets confusing. Let's go now to the tapered piece. The tapered piece would be right here, right in here. The pitch is 5 degree, is a 5 degree pitch, meaning that this is a high side here, and everything will be going down to a low side, right? And the pitch is going to be 5 degrees, right? Now, tongue and groove boards, these right here, these yellow members, those are your tongue and groove boards. They're going at 150 mil by 25. The fascia board, let's see, we can't see the fascia. Let me just move the detail. Let me clear the drawing. Let's highlight where the fascia goes. So that's the fascia here. That's the fascia. Built up felt thickness is 5 mil thick. And that would be, the felt would be at top here. And that's the last material. So that's the material that takes on the weather, the built up felt. And the aluminum flashing. And again, the aluminum flashing, we know flashing is going to be placed in this point here. And flashing is going to be placed at another location where the parapet wall meets the actual roof. So let me just look at it again and highlight the areas, both areas where flashing is going to be placed. So flashing is going to be around here, and the flashing is going to be around there. So that is flashing. Right? Now, we're going to follow these specifications and we're going to draw them. So now that I've laid out the specifications and we join this in orthographic projection, I think that everyone at home should be able to follow along so far. Now, I am going to clear the screen and start drawing. Let's clear the screen. And if I need these specs, I would, revisit this later. But for right now, we are going to be drawing. So let's find a nice spot here. And I'm going to start alpha line. And the first thing I'm going to do is, I think we should probably draw it here so that people can see what I'm drawing and can see the detail close by. Alpha line, and I'm just going to draw down the line. I'm going to keep my ortho on by pressing F8. So just projected a line down, which is a vertical line. I'm going to offset now, 150 mil. That's 150 mil. What's the span between? I'm going to measure. I use DI sometimes to measure. And that there's 3,000. Offset 3,000. And then another 150. Okay. Then I just cut that. Just put a random line across, so I know this is where I'm going to start my roof joist. My roof joist is also 150. So I've offset 150 millimeters going up. I've done that, and now I can start trimming. Just one more. There. Just to get that there. Now, if you look here, the roof joist doesn't go directly through the concrete block wall. It goes halfway in. So I'm going to set up mine like that also. Trim over here, and also trim here. Move this detail a little closer so that I can see exactly what I'm doing. Cool. All right. So that's in. Now I'm going to project a little bit upward, just a random distance. That this is where my parapet wall is going to end. Okay. So my parapet wall is going to end like this. All right. Cool. Now, let us put in this slope. So the first thing, before I put in the slope, let me also put in the tongue and groove boards. So for these tongue and groove boards, these going at 150 by 25, right? Right here, 150 by 25. So that means the thickness that I'm looking for this detail is a 25 offset. So go here, offset 25. Check that up. Now, also, I'm going to project another 25 up for my high point. No, I'm going to, let's measure here. How much is my tapered piece? That is 50. So I'm going to project 50 millimeters up. That's my high point. And then I'm going to bring this down. What we can do is we can actually rotate this 5 degrees. So you're going to rotate, and then you're going to put 5 degrees here. Right? And now I'm going to mirror and erase those object. Yes. So now that I've mirrored it, I'm going to move it now. And this is going to be my, well, that 5 degrees, very, very steep. So what I'm going to do is I'm not going to use 5 degrees, to be honest. I am going to wing it. 15, and then 50, then you're offset 5. Okay. And then what I would do is I would make sure that the low side comes in at 5 mil. So the high side is 50 mil and it then tapers down to 5 mil. I think that's a good job there, a good solution. Now just clean it up. All right. Just check back the detail here and see what do I need to insert. I need to insert the fascia board at the end, and I need to also insert the drip button. All right. So the fascia board, I know that fascia board comes in 200 by 25. So you're going to offset the 25 here at this point. Yeah. And where does the 200 come in? I like my fascia board always covered the inside. Just do that. 200. Yes. Okay, that's my fascia board there. And I am going to put in a drip button. And this will be my drip button over here. Let's measure this and see how much this is. That's 15 going, let's call it 100. 15 by 100 is my drip button. So I'm going to offset 15 from here. Find a spot. Fill and offset 100. You can skip it. I'm just going to bring these up there. Yeah. Or some people round this material off. They can fill it radius, and you can put in a radius about 50. And this would have to round that off there, so like that, if you do want that as a style for your detail. You know, I'll probably do it. That looks a little smoother, so I'll just do that. Right? And then your gutter will go right here. So let us see what's the size gutter I'm using. Let me just measure the gutter here. My gutter is about 68 diameter with a thickness of about 5 mil. So I'm just going to create a 68. Just create a semicircle. 60 for diameter, 68, offset 5. On the outside, yeah, slice it in half, and then trim. And then trim down here. Make this material 5 mil thick. Trim, 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 trim. Okay. I can grab this, and I can then put that in somewhere here. Right. And this would then be my gutter. And that receives the water from the roof, and then that will be channeled down through a downpipe at a later point. But we don't have to worry about that now, because our detail we are drawing doesn't have that in. All right. Also, at this stage, I'd like to invite everyone to save their drawing Control S saves. That's a quick way of saving the drawing. Now let us proceed. Now, so this is pretty much finished. I need to add materiality. So I have my tongue and groove boards here, right? Let me just bring this up and let me just analyze this because I am going to show you all how to create the tongue and groove board, but I'm also going to be inserting from my block menu. So the first thing is we draw a rectangle, right? And the rectangle is going to be 150 long by 25 thick, right? 150 long. Okay, cool. What I'm going to do is I'm going to split this in half right here. Like that one. Let's measure this tongue. How thick is the tongue? Tongue is 5 mil. So that leaves 10 mil on each side. 10 mil on each side, and the tongue is 15 mil long. So I'm going to offset 10 mil from the sides first. 10 mil and 10 mil, and the space in between here will be the tongue. And then I'm going to offset 15 mil from this edge up here. Then what I'm going to do is fill it. Oh yeah, I need to change my radius back to 0 because it was at 50 when I last filled it. So that's there, that's there. Then I'm going to trim. That there will be my tongue. So we have a tongue, we don't need a groove. So how does this work? So I'm going to copy this right to here. Oh there. And by doing that, I have a groove. Just trim this right there. So naturally I have the tongue and I have the groove. So that is how you would create your tongue and groove boards. Then you would put the material inside. So what's this material? Let me explode this so I can then reference this material. This material that I've used is a hatch. I've used the hatch user right here. The size is 5, which is the spacing, 5.0, and the angle is 45. So I'm just going to place that in now. And that there is how I've actually created my tongue and groove boards. All right. All right. Just going to close it off. And I'm going to copy in mine from this. The tongue and groove boards will go here. And I'm just going to stamp these in all the way to the end. You don't only find tongue and groove boards in roofs. You can also find them on timber floors as well. I did this in a detail in a previous demonstration. Okay, my tongue and groove board fits right up to the edge. I like when things do that. That means I don't have to reduce or do much trimming. So you can just bring this back here, and that's a clean finish. A clean finish. So my tongue and groove boards are in. What's the next thing that I need to insert? My tapered piece of timber that is already in, and my flashing. Now my flashing is going to be a thickness of, what is my flashing going to be a thickness of? It's right here, it's a triangle piece. I'm just going to put that in as a triangle member and call that up as flashing and put some hatch in there to fill it. But the built-up felt goes in at a thickness of 5 mil. So let's put this triangle member here in. Just from here, and you just draw it. Yes, that's it. Then I'm going to hatch there and call it up as my flashing. Now, what else do I need to do? I am going to start putting in my felt. Felt. And this here goes through here. Should be down proof number. It goes a little bit into the material. Okay, so set to get my 5 around here. And this is where the material would end there, right? Material then we go over here. Let's end the material around here. All right, cool. Now, what do we do? What's the next step? Next step is to put in the material hatch. With this one, I'm going to put this in a solid fill. Yeah, that's good. And I'm also going to put this one in a solid fill as well. Yeah, that's a solid fill as well. We're going to put this as a hatch, and I'm going to put this as user, because I want this to show the grains of the timber. The angle I'm going to put at 0, because I want it to be horizontal. I'm going to put it at about 10. Let's go 15. Yeah, 15 looks good. So that represents timber. Yeah. Now, let's cut off here, because I'm going to put a hatch in here, and this is going to represent the brick wall. So I'm going to match the hatch from here over. These represent the brick wall. Okay? Good. Now, what else do I need to do with this detail? I need to insert the coping, which is right here. What I'm going to do is give myself 50 over there, 50 up. I'm going to wing in it from here, 50 to the right, 50 up. Do that. Find the midpoint here. Just go up and this thing into action. That's it there. Let me create a circle in here. Yep. Let me mirror it up here. So that they give it kind of good. Yep. Erase source object. No. That's the coping there. Nothing more to it. That material would be solid concrete. So just watch that. Then I'm going to match it. And A to match drop. Grab the material from here. And then put it there. That's solid concrete there. I mean, the solid concrete, I use air con. My scale is 15 and I do nothing with the angle. I don't bother change the angle to that one. All right, now, last thing. I need to label this. Label. So, what's this label going to do? I'm going to be pulling the labels from this join over to here. Just to get one label. So this is a coping. Right? And then this would be damp proof. And this would be flashing. Let me just change that to there. That would be flashing. That would be damp proof. Damp proof force. Right? And this will be our flashing. That will be metal flashing. And what else? And put a little order to these. So that 0. So that to do. That to do. And that to do. Right. Then we have the floor joist, not the floor joist, the roof joist, sorry. My bad, my bad. Call that the roof joist, roof joist. That is 150 mil. Yeah. Built-up felt needs to go there. So I will also bring some notes on this side here. So how am I going to do that? Copy this around. This will be the built-up felt here. Let me just label it up. Built-up felt. That's our built-up felt. Yeah. And then we're going to need a note to call up. Internal groove boards. Tone and groove boards. Tone and groove boards there. And I think I've gotten everything I need in this detail. The tone groove boards, the built-up felt, metal flashing, the damp proof course, the coping, the roof joist. Let's see what over here has. Oh, I need the fascia and I need the gutter. All right. So I'm just going to move this detail so that I can have more space. Let's grab this note here, which is the fascia board. And I'm just going to stick it in right here. That's the fascia board. And then this note now is the gutter. You got here the fascia board. And what else do I need? I need the drip bottom. Yeah. And that should be basically it for this detail. The drip bottom. And I think I'm good. Let's put an X through this, or we can patch this as a timber member because they're both timber members. Yep. Okay. Okay. So all this detail needs now is some labeling, and this detail is good to go. So this detail is, I'm going to bring the label from here. What's the size of my label? 228. Right? I'm going to bring it out. Let's copy these out. And just put that here. I'm going to reduce this. I think this is too large. So I'm going to put this at 200. Yep. Now at 150. Let's see how 150 looks. I think 150 looks better. We'll bring this up closer to here. And let me reduce the size of this to go to something like 75. Easily 50. It's 50. See? All right, yeah, and we'll put a line through and bring this up to the line. Bring the line, move the line slightly. And bring this back across. Cool. We'll leave it there. Lastly, I'm going to go on to my outline layer and then just match up things that need to be in the outline layer. Okay. And once we have finished creating one of these details, we can simply copy and paste and then just do some editing to create the concrete timber roof. Sorry, the concrete roof detail. That's the next thing that we're going to be doing. All right. So I'm just matching, max dropping, or max cropping all the lines that I want to be in the outline layer. Yeah. So I think I've done everything there for that. So this is the timber flat roof finish. I'm going to copy this. I'm going to save. Control S to save. Don't forget to do that. And I'm now going to copy this out. So let's copy this out. Now. Copy it down. Yeah. So the first thing is I can change this material to timber, and then I can remove this. So the whole groove board system wouldn't be there. That wouldn't be on the flat roof concrete here. So I'm just removing this. That's the only glaring things that have to be removed. So I'm just going to do that now. And what that means is that the timber tapered piece is going to be larger in the concrete flat roof than it would be in the timber flat roof, because I've removed the tongue and groove boards, so I've given myself a larger space to deal with for the timber tapered piece. But it's not going to be timber in this one. It's going to be a mixture of cement and sand to create a screed. So I'm going to hatch that with some sand particles to represent that. All right. So I'm just cleaning up my drawing now at this stage before I go any further. So I'm now going to max drop the concrete here and put it here in here. Right. That now is concrete. So now I'm going to change the note to concrete slab 150 mil. What I like about AutoCAD is if you write all of your text in lowercase, you can come in here and just press this and it brings everything to uppercase. Super useful, super useful. So this now will be called sound and cement screen. Okay. Put that in all caps. Now I'm going to actually hatch this. And I'm going to put it as air sound. Air sound. Put them in the particles thing. Just change the actual layer that is in, needs to be in the hatch layer. Okay. So that layer is in there. I think those are too much, so I'm going to reduce 10. I'm going to actually increase 10 to 15. I want the 420. The 20 looks good. It's not too dense. The damp proof course remains. The metal flashing remains. The built-up felt remains. The drip bottom, the gutter, and the fascia remains. And all this is happening on a concrete block wall. So let's label that concrete block wall. Concrete block wall. All right. Let me put this into uppercase. Yeah. And that basically is your your concrete flat roof detail. I'm now going to put in the steel members. So I'm just going to draw a line here, like that, like that, and this would indicate that there is steel in this detail. I'm going to thicken this, probably 2 inch, 2 millimeters thick, sorry. Offset, 2 mil, to give it some thickness, right? Thinking of doing this, just giving it a bend. So I'm filleting this, but I put in a radius of 25 to give it this curve. Close off the material though. And the next thing I'm going to do is I'm going to put some small circles in here to represent the steel bars. Seven, copy. You know what? Divide div. Let's choose a number like 10. And we're going to copy these. The rear, we put in 10. And I think that we're going to copy these at every point. Okay, good. So that's how far 10 got me. So what I'm going to do is I'm going to copy these things. Yeah, that should get me the full line. All right. I'm going to turn off my point system so that we don't see. So those are the steel bars in there. I think I should hatch them. Solid hatch. So I'm just hatching steel bars, solid, just enhancing this drawing them. And of course, this is the concrete flat roof detail. Once you see me put in the steel bars, you know, steel goes with concrete. So this is the concrete flat roof detail. All right. So that is in there. So I can adjust this by calling this a concrete slab with steel bars. Or I can put 150 mil concrete slab with steel bars. Yep, that reads better. All right. So one thing I need to do is I need to change this title to reflect what I've just done. So this would now be a concrete flat roof detail. So I've done both my concrete and my timber flat roof details in an orthographic projection format. Now I'm going to do them in a isometric format. I hope so far everyone here is understanding what I'm doing. I'm creating timber details and flat roof timber flat roof details and concrete flat roof detail. Right? This is a sectional detail. That's what I'm doing. Now I'm going to move on to creating these isometrics. These isometrics shouldn't be too difficult once you have created this and you have all your measurements here. So the first thing is I'm going to turn my mode of drawing to polar tracking. To find the polar tracking, you can just go and hit F10, or you can come down here to your taskbar and you will see it here. And this is what it looks like. So I've turned on my polar tracking to 30, 60, 90, 120 degrees. That is what I always use when I create an isometric projection. I used to use the ISO draft tool, but I find that that takes too long. So I wouldn't advise anyone to use that. I would always advise my students to use the polar tracking technique. Anyway, let us go. So I'm going to create this now. I'm coming up here. Then, okay, let me put that on. That will be around 15. That wall goes up to some level. Okay. So straight away, this is how I've drawn one face already there, right? I think I'm going to run into some space problems. So I'm going to move this, I'm going to move this around so that I have enough space to create my detail. I want to create my detail while observing this timber flat roof isometric so that while I'm enjoying this, my viewers can see what the final result will look like. I think that's very important. Just send this back some distance. And I'm just sending these back at random distances because once I work with the dimensions that I'm supposed to work with, the length that I'm sending this detail back, it doesn't really matter to me, right? That part there isn't important. And if you follow this tutorial at the end, you would understand why that there isn't that important. The parts that have specific dimensions are the parts that are important, right? It can go back any length. All right, so I've created this now, and I now need to create a span. A span of 100 of 3,000, right? 3,000. Yeah, and then so I've created that span 3,000, and I can copy this now over there. So I've just inserted my two walls. If anyone wondering what I'm doing. All right, this is taking up space, so let me move this. Let me move this down here. That's the best thing. Let me move this down here. So creating my span, my two walls. Now what I'm going to do is I need to start somewhere. I just bring it around here, and I'm going to create my roof joist. So this is the line that I've chosen where I'm going to insert my roof joist, which allows me to have this space remaining from here to the top. This would be my parapet wall. So I decided to just put my roof joist in here. For those of you at home, I just chose this random spot right here, and it's just showing it's random. Just choose a spot and then start detailing. All right. Don't really get too caught up with what measurements, how far down that is. That is not important at this stage. Now, what is important is this next step. I need to make sure that my roof joist is 150 mil, and I cannot offset. So I'm going to grab this and I'm going to copy, and I'm going to come up, and I'm going to be going up on this path, and I'm going to type in 150. So that's how I know that that is 150. That there had to be a specific distance. I'm going to come in 75 here, which is half of 150. And I'm just going to screw this up, okay? I need to change my fillet. I had it at 25, I want it back at 0 so that I can get my square effect like that. So that is in. Now I'm going to do the same thing here. Come in halfway, which is 75. Bring this down and fill it. All right, trim it here. Cool. Right. So that there is my roof joist. But my roof joist has a thickness also, right? So let's just now insert this thickness by copying. And this goes across 50. Right. So that's that timber member there. I've placed the thing. Fill it here. Let's clean it here. Now let's bring this down. Let's clean it here. I turn that over and fill it. All right. So that's there. That there is my timber joist, my roof joist. All right. This would occur at different intervals as we go down. Now, what's the next stage? Next step, I'm going to be inserting my tongue and groove board. So my tongue and groove board will come above here. So let's give this some distance to breathe. So I'm going to give this, let's give it about around 50. Around 50. Yeah, this is, let's start the tongue and groove board around here. All right, so that's 150. My tongue and groove board, copy this up 25, because I know 25 is the thickness of the tongue and groove board. Yeah, that's it. No, I'm not going to put in all of those extra details. Actually, I'm going to put in one and then copy. So copy, and you will realize that in this isometric mode, I do not really offset to get distances. I usually copy, because if you offset and you don't know to use the offset in this mode properly, you will get a skewed distance. So the tongue groove board comes in at 25 by 150. All right. Now, copy. Copy that down 10. Copy this up 10. Then copy that out 15. Now, let us do this up. There's the groove and the tongue. One time. Sure. Oh, it's just this thing. Okay, cool. So I'm going to copy this expression. Now, let's copy it 20 times. So, okay. I think it did well. Yeah. I copied the expression 20 times and it did well. That's as far as I should have trimmed in between here just to make it more realistic. I'm just going to do that. If I had done that all one time, I wouldn't have to come back and trim these. But can't remember everything at the same time. You know, it happens. I'm just going to clean this up right now. By the way, if you haven't subscribed to the channel, take that this is a good opportunity. This is a good time to subscribe to the channel now. We have some geometry, technical drawing, geometry exercises, demonstrations there. And we also have building drawing. And we got a bit of Krita art. So if you haven't subscribed to the channel, you might want to do that now. Now, let's send this back. And again, this is going to go about some thickness or some depth. I'll just choose a random point here and I'm going to send it back. Now, what is going to be interesting, I'm going to copy these. Copy this. A to array. Then I'm going to copy it 20 times. And I'm going to put that there. Good. So copy that 20 times. So that's the tongue and groove board that goes back there. That means the board ends right here. So I can then just do that, right? That's my board. You're not going to see the board. You're not going to see this wall. So I'm going to just remove this bit. You're not going to see this part of the wall. So I'm going to trim that and remove this as well. All right. So my tongue and groove board. You know what? I'm going to end it here. Yeah. All right. So my tongue and groove board is in. Tongue and groove board is in. My roof joist is in, and now my furring piece needs to go in. So again, I'm going to come up here, give myself 150. Yeah, a piece. Again, copy this up. Uh, 15. This is where it's going to get interesting. Then on this side here, I'm going to go up 5. Right? It's okay. Let me make sure we go 5. And then we're going to just stretch that down to the. So up here is 25. And then we're going to just trim all in here because you won't be able to see what's going on in there. Right? So drawing these isometric details is a process of cleaning up the drawing as you go along so that you would understand the drawing. You don't wait to the end where all the lines are in front of your face and confusing you. So that's one thing I would always advise students. When you're drawing, clean up your drawing as you are progressing. Don't wait to the end because sometimes there are too many lines on the screen and you honestly don't know what to remove at that stage. It's too late and it gets too confusing. Right? So let's give this a thickness, a random thickness there. Mm, I'm just cleaning up here by trimming these bits you wouldn't be able to see. After this, I'm going to save before we go on to the next bit. I also advise you students or you viewers at home to save this drawing. We've done a lot. We wouldn't want any tragedies to happen. Right? Always remember to save the work. Always. Right. Then, so we have our paper piece that's in. Then what's the next step? Now let's just look back here and see what's the next step. The next step is our flashing. Flashing is going to take the same shape of the paper piece. And then after flashing would then be my coping. All right. So let's take this profile, copy it, CO for copy, and just pull that up. Pull that up here. We'll just enhance this. This will go up, like that, and then that would be that's the general profile. I think I should probably even do this to acknowledge this is where the flashing bit goes. All right. So what am I going to do now? I am going to copy. Yes, not offset. I'm going to copy this. Copy. Just bring this out slightly. And I'm going to bring it out 5. Yeah. 5 is a good thickness. I'm just cleaning up in between. And once I've finished cleaning up in between, I can possibly hatch in here so I can give this material a thickness. And this that I'm cleaning up would be the built-up felt material. So this is the last material that is added to the roof. And this is also the material that takes on the weather. So the sun shines onto this felt and the rain falls onto this felt. So both the rain and the sun actually go onto this material. So this material is what protects the roof from getting the moisture and from getting any rain coming inside. Very important. Built up felt. Remember it. All right. Good. Okay. So what am I going to do is I'm going to clean this up now. You're seeing that I'm sure I'm going to clean this up. You're not going to see any of this. Yep. Because once the felt goes here, I'm now going to copy this whole expression. This is how down the material would be. All right. Get rid of these details in here. And I think I've done it. Let me hatch in here. I honestly don't know what to hatch there as. So we'll just let it hatch there. You know what? I'll leave it off. I don't want to complicate the thing. That's what I'll just leave it off like that. If I don't know what to put in there in terms of a hatch. All right. Just leave that. What am I doing? Let me just go back somewhere here. All right. Now the last thing is the coping piece and the parapet walls. So this goes right here, and if we were to follow this, my wall will come in somewhere. Yeah. Mm. Ah, see what's the issue? Need to extend this. Probably about 50. So is it 15? And like this, this, No trim. In there. All right. I want to give this point here. Yeah, trim, trim, trim. Yeah. I think that looks good. That's the profile there that I'm looking for. That is the exact profile I'm looking for. Yeah. And now I'm going to send this back. You connect these lines. Mm-hmm. All right. Okay. So I think I've got that in. Now it is time for me to start putting these things into the correct layer. Want all of my group boards into my construction layer. It reads better. Okay. I got to put these ones back here. Mhm. Having knowledge of how to green and blue grab is very important, and it comes in handy, especially when you're doing these drawings. It really does come in handy. So you can grab multiple items at one time. Mhm. So I'm going to put this in as reference. Let's drop that. That's in there. You're going to also put this in as reference to makes a lot of sense that you can see the different materials. You can see each material has a different line weight. Mhm. So everything that is supposed to be in is in. Let's see, what is this? This, I don't think that is necessary. Mm, So those are the layers there. So this goes like that. No. Continues and this continues. So we gotta throw that back to the continue, 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 and that's how that is treated. Break this, BR, the break. Can you see that? And let's match drop this. And that's it. All right, now I think that this detail is pretty much done. Pretty much done. Yeah, it's pretty much done. Let me just label. Let me grab the labels from here and bring them down. And I'm just going to put them in and go through each one. So this is the coping right here. Now also known as the built-up carpet. This is the flashing right here. This is the built-up felt. Right there. Tapered piece. We'll go somewhere right here. Yep. The block wall, you can put that further down. It's 115. That doesn't need to go all the way there. I can go there. And then there is the roof joist. That goes in right here. Timber member. Right. Now put in come on, roof board is the only thing missing. Let's insert that. And that it goes right here. So those are all of my notes in to make this detail come alive. Thinking of doing that, yeah. To give that some sort of a materiality, saying that that is the end that we're going to see. I'll just put it here con. Yeah, and then I'll put it at about 50, 25, 25 seems reasonable. So that there would represent the built-up felt. Let us now put material onto the brick wall. Let's go, material, brick wall. Right there, right there. Let's drop this. Good. Good. This is also a brick wall here. Let's drop that. And then the coping itself, the triangular shape at the top, there, that will be solid concrete. Yeah, left the solid concrete. That's there. And that's my detail finish. Now, all that I need to do is I need to label this. So I'm going to grab this because I like the size over here. I'm going to just bring it down here. And let's call this concrete flat roof detail. And this was done in an isometric projection. Isometric projection. So that's it. Now, one more to do, and then we finish. But as usual, we can copy this out. No, this is only concrete flat roof detail. My bad. This is actually timber. What was I doing? This is the timber flat roof detail. Yes, because it has in the tunnel roof boards and then the taper piece. All right. Now, what we're going to do is we're going to copy this out right to here. And what we're going to do with this now is we're going to remove the tunnel groove board. And by removing that, we would have a bigger tapered piece. And it's not going to be timber this time. It's going to be a mixture of sand, screed, and cement. Let's remove this because this is no longer needed. Just give a moment to remove this. Which gives us some space. Let's see, can we go? We should be able to do that. That'll be. Again, having knowledge of how to blue grab, handling grab saves you a lot of time, and also having knowledge of how to copy and array when copying saves you a lot of time again. These are the techniques that I will tell students to try to master early out when you're creating these drawings. Why should you master these? Because these will save you a lot of time. And if you don't like to save time, then just, I don't know what to tell you. Just copy this down. I'm going to give this an increase. And then that means I'm going to move this down to this. Right? So that member gets thickened in the concrete. And this to fill it down. Fill, move down. All right. So now we're going to call this now sand screen. Sand slash cement screen. That's that there. And then this isn't going to be our floor joist. This is going to be our C slab, 150 mil concrete. Reinforced concrete slab at 150 mil. I'll put with steel bars. Right? So that's steel bars. So perhaps if we can put in the steel bars. Yeah, we should put in the steel bars. So people will be able to see what's going on there. So how do we put in steel bar? I'm just going to do that. Yeah, okay. We've got a little curve. We bend in the steel. Offset this. 2. 2 mil. And that's it. And now we need to put in the isometric circles. So how are we going to put in this isometric circle? Well, there's a quick way to do it. I'm going to draw isometric box. Let's draw a box at 25 by 25 by 25. That's 25. Go to the longest point. Not going to spend a lot of time explaining this process because I actually have a tutorial going through this in a lot of detail. So this is just a quick something here. But for those of you who know, they know if you want to get better at drawing isometric circles, I suggest you can check out my tutorial. I will place the link in the description. Oh, look, you see? Copy it up. So I have here an isometric circle. So what I'm going to do with this is I'm going to push this back. I'm going to push it forward like this. Yeah. So you can see how this comes together. And these are the bars here. And projected out. Right. That turns off there. Okay. Just doing some cleaning up. So I've just inserted my steel bars. I'm cleaning them, clean up my detail. Mhm. That's my, that's my concrete. And this concrete runs right through. See how this is going. So this part here is slightly confusing. Let me make sure I don't confuse my audience at the same time. This is the part here. That means trim. Right. Right. And again, I just put in a random size to just give this some sign of the concrete steel. Sorry, the steel. I think I've been on this detail for too long. This represents the steel bars. So that's it. Cool. That's the concrete. Sunscreen, build felt, the flashing, the coping. No. Input. Let's drop this now. Change the material here. And that there is it. That is it. This material here is the brick. The surface off here. Which needs to go. Match up. Yeah, yeah. Perfect. So that's in. That looks good. That looks good. I don't know what else I can do with this material. I mean, with this detail here. I think it's pretty much done. And then we're going to do it is follow up the down proof. Here as in U, 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 U. Yep. Also going to follow up over here on this detail as well. U, 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 which stands for damp proof course. So I've completed both of my details. My timber flat roof detail and my concrete flat roof detail. Both done isometrics, both done in orthographic. Now, the last thing I'm going to do is to put all this into a nice presentation so that we can review this, call it a day, and get out of here. I'm going to copy this around. And grab these two, move it, put them in here. And I'm going to grab this, move it, put that in there. And I'm going to grab this, move it, put that here. Flat roof details is the title, and we have come to the end of our presentation. This is a concrete flat roof. I didn't bother to fully present this because most of the things that are on this detail would have occurred on other details, right? But I can just go through this. This is a flat roof detail with a parapet wall. The aluminum flashing is there. Right here is the aluminum flashing, and it's represented with dashed lines. Right. This is the material, is a rubberized spray, water-resistant application applied to RC roof slab, slope to drain, which is right here. But the one that we were focusing on, they used built-up felt. So I didn't bother to confuse my students, but you could have used that as an alternative layering material. Now, what did we do today? We had a long session and we went through flat roofs. We described, I explained what a flat roof is. And there's one term when we're dealing with flat roof that you keep hearing all the time, which is roof flashing. I explained what a roof flashing is and what it looks like and what's the purpose of having roof flashing onto your flat roof. Okay. I also showed examples of flat roof. I showed how the water is distributed from the flat roof and the style drains that we can adopt. I also went through the specifications for designing a flat roof. I also showed a 3D model detail and exploded isometric detail here, and also a detail where all the materials are linked together as it will function in reality. What else did I do today? I also went through a strategy as to how to set up these flat roof details and how to go about drawing them. And then lastly, I created 4 drawings, 2 orthographic projections and 2 isometric projections. This now brings us to the end of our presentation. I hope everyone learned something new today. If you did, please like, share, and subscribe. And lastly, I would encourage all my students, all my viewers to practice this. Firstly, you should probably practice by sketching it. Get out a pencil and sketch this onto a plain piece of paper, understand how this works, and then come to AutoCAD and do it. All right. Again, if you're having any difficulties, replay this video and watch it in slow motion. Stop, make your notes, and then proceed. Stop, make your notes, and then proceed. That is the strategy that I'm going to give to you all. I am out.